Hi, my name's Kyle Brandt. I'm an original co-author of the Bosun monitoring system. Bosun is an open source monitoring system created at Stack Overflow. The system's primary focus is on a learning and time series. So in this first video, we'll talk about Bosun, time series, and OpenTSDB's data model as an introduction to the system. So we need to know what a time series is. A time series is a series of observations, each recorded as a time and date with an associated value. So we have an observation such as August 22nd at 10:20, and the value might be 10, and then we'd have another one 14 seconds later where the value is 20, and so on. We usually plot these on an axis. The x-axis is time, and the y-axis is our values. And then we plot each observation. So the first one at 10 with a value of 10, the second one 20, and then we draw a line between them. Bosun queries a time series from a time series database. Its primary one is OpenTSDB, although others are supported. OpenTSDB stands for Open Time Series Database, so it's a database that stores time series. Each time series in the database is uniquely identified by a metric name as well as a set of tags. And each tag is made up of a tag key and also a tag value. So the identifier is the metric name plus the tags are a tag set, and each tag is a key and a value pair. This is Bosun's graphing page, which queries OpenTSDB, our time series database. So the first thing we have here is the metric. So we can enter in a name for the metric, such as linux.net.bytes, which is a metric representing network traffic on our Linux devices. And what gets loaded over here is our tags. So we have a set of tag keys here, such as host is a tag key, direction is a tag key, and iFace, which stands for interface, is a tag key. And if I put an asterisk in each one of these, I'm going to get all the time series back as they appear in the database once I hit query. So this is a lot of time series, and we can see them here, and something interesting happened around this time on what seems to be the Colorado TSDB servers. So what we have uniquely identifying each time series here is the metric name, linux.net.bytes, and then we have our tag set, which is a set of tags, which again is a tag key value pair. So direction's a tag key, in's a value, host is another tag key, and COTSDB02 is a tag value, iFace is a tag key, and EM1 is a tag value, which is the interface, the host, and the direction. So the metric name plus the tag set is what uniquely identifies the time series. And as you can see, we have a series of observations for each one of these spanning over time. OpenTSDB can return time series that are different derived time series from our raw data in various different ways. The first of these manipulations we should be aware of is aggregation. Pointwise aggregation takes multiple time series and derives a new smaller number of time series by using an aggregator function, and it does this through reduction. And there's different types of reduction going on in Bosun and OpenTSDB, so that'll be something you'll be hearing about more and more. So an example aggregation would be taking the sum of multiple time series. So we might have something like the number of customers coming through the various stores. So let's say we have, I don't know, these are days, and you could say millions of customers. So we have 1 million the first day and 2 million the next day, etc. And then we have another store in New York with a different set of customers. What we might want to know is the total amount of customers for all of our stores. So we can start to add up each point. We take the first one, which would be 1 plus 3 million, which gives us 4. And then we do that with the next point and the one after that, etc. And we get this new derived customers, and this is really the sum of all the customers based on our two locations. Another aggregation we could do is take the average number of customers going through each store. So we'd take our 1 in 3 million, and that would be 2 million, would be the average between the two. And if both of them were 2 on the same day, 2, etc. And we keep going, and what we get is an average number of customers for the total stores. So this is aggregation. It's pointwise, and you can really think of it as a vertical operation because we're taking each observation in time and adding it vertically along the y vertical axis. Returning to Bosun's graphing page, which queries OpenTSDB, with our linux.net.bytes example, we can see we have, again, the asterisks for all of the tag values, and we have a time series for the direction, the host, and the interface, a unique time series for each of these. And the way we can start to trigger aggregation via this interface is to start to blank out some of the tag value fields. So for example, if we first get rid of direction, we're going to see the total, we're going to get a time series that's the total amount of network traffic per host and per interface. And now we can see that our tag set is just host and just interface, and the traffic is the total because our aggregator, our aggregation function, is set to sum. We can repeat this process and get the total per host by blanking out, in addition, the interface value. And now we have only the host tag key value pair, and we see the network traffic total per host. And if we want, we can get the total for all things that are in the OpenTSDB database and have them all aggregated by the sum function. And now we have the total amount of network traffic for all of the Linux devices that are in the database. We can also choose different aggregation functions, such as average, as we saw before in our slides, and get the average, which is on a completely different scale, as we can see. Now, and a thing to be aware of is that throughout these different time series, the data points will not always be lining up. So what's going on here is that OpenTSDB is essentially creating data points for us so it can line them up and do our aggregation. And that does that via linear interpolation, which I'm not going to get into, but you can read about it in the OpenTSDB documentation. And you see these Zim functions here, and what those do is perform similar functions, but they don't do the linear interpolation. So you should be aware that when you're querying the data that these different behaviors are going on, especially for sparse data, and when you start to see things that maybe don't make sense to you, you need to be aware that behind the scenes you might be having that linear interpolation going on. Another way which OpenTSDB manipulates our data is to do rate calculations. And we also, in the graphing page of Bosun, you'll see this is a series type. So there are three ways to query a time series in this regard. There's a gauge, and that's just querying the time series as it is, and it's generally used for values that increase and decrease over time. We can also calculate a rate. So with that, we take the change of values to convert the values to a per second rate. So the formula for this is to take the first observation's value and subtract that from the second observation's value, and we divide that by the first observation's time subtracted from the second observation's time. And what this gives us is the change in value over the change in time. So for example, we have an observation at 1 o'clock with a value of 10, and another observation at a value at 1 o'clock and 10 seconds with a value of 30. So we have 30 minus 10 over 1 o'clock and 10 seconds minus 1 o'clock, which gives us a value of 20 over 10 seconds. And what this equals is 2 per second. So the derived observation we get from this is 1 o'clock and 10 seconds. It'll register as the second observation's time, and a value of 2 to represent 2 per second. Finally, we can also do a counter. So this also takes the rate. It gives us a per second rate, but it never lets the rate go negative. So it's for things that are expected to always be increasing but reset once in a while. And when it resets, it will set it to a value of 0 in the current version, and I believe in future versions it'll drop that value, which would be preferred. In Bosun we have the series type here, and currently it's set to auto. What auto means is if a sender has sent metadata about a metric, one of those pieces of metadata can be the series type. So it's going to default to whatever the sender recommended we use, which in this case would be a counter, which shows us the per second rate of bytes here. so it looks the same as a counter would. If we query this as a gauge, we can see that everything is just constantly increasing, which isn't a very useful visualization. But it's a good way to record data because it means between observations, even though we might not know the shape of data, we know the quantity of data that happened between those two observations. The other one here is rate, which is like a counter, but it doesn't handle those resets. So to look at an example when we might want to use the rate is something like Redis key count. So this is the number of keys in all our Redis instances. When we query it as auto, it's going to be a gauge. And this is the total number of keys, which is something we might want to know, but probably more useful would be the rate of keys being added and removed to our Redis instances. So we can do the rate, and as we can see here, this lets it go negative, whereas that would not happen in a counter. The final manipulation of time series data that OpenTSDB does that I'm going to talk about is called downsampling. Downsampling takes a time series and reduces the number of data points in the series by using a downsampling function to reduce multiple data points in a given time window to a single data point. So let's take this example, and let's say this is our customers again, but this is a measure of the current number of customers in a store at a given time. So we have, and on the x-axis, we can regard those ticks as days. So we've taken multiple observations throughout the day. So what we can do is downsample this to figure out the average number of customers that were in a store based on these observations in a day, as opposed to having multiple observations throughout the day. So we take our first time window of a day, which has 2 data points in it, 1 customer and 3 customers, and we downsample that by taking the average to 2 customers. We can repeat this for the next time window, which has 2 customers and 1 customer at the 2 observations, and we reduce that to 1.5 as an average. And we repeat that for the final time window, which has 3 data points, but it doesn't matter, we're still taking the average, and we get 3.5 customers at a time. And this gives us our new time series, which is a downsampled time series, aligned to 1-day windows, even though we had multiple observations throughout the day. In Bosun's graphing page, by default, auto downsample is checked. So what that does is when you graph a long period of time, it will try to figure out roughly to have 1 data point per pixel and downsample using average accordingly. But if we uncheck this, our downsample options appear. So we can pick a downsampling function such as average, and we can set our own custom time window. So we could set it to say 20 minutes, and this is over 1 hour. So when we query it again, we're only going to have 3 data points making up 1 for each 20 minutes, and that was the average of what we saw over those 20-minute chunks windows of time. The final thing I want to point out here is that we can see when we do these, it's building a query here, and this query is Bosun's expression language, and it's what we use in the expression language to get our time series. And what this returns is what's called a series set, and this expression link takes us to the expression page. And this is what we'll be talking about in the next video. In summary, we learned about time series, and we noted the time series are just observations over time. We learned about OpenTSDB's time series data model, which each time series is uniquely identified by a metric and a tag set, and each tag is a key and value pair. We also talked about data manipulation in OpenTSDB. You can do aggregation, which was the vertical reduction, adding up data points that are around the same time. We also learned about linear interpolation briefly. I didn't go into it, but you can read about it in OpenTSDB's documentation. The main thing to note is that it'll add points to fill in gaps and can change your data in some ways. We learned about rate calculation, which is when we take the data in OpenTSDB and derive a rate from it, or possibly a counter, which is also like a rate but won't go negative. And finally, we talked about downsampling, which was horizontal reduction. So we take a window of time and we apply a reduction function to it to get a single data point for that window of time.